The ammunition of 105mm size towed artillery mainly consists of two parts, the projectile and cartridge case. Propelling charge is located inside the cartridge case, and there's a primer at the rear of the cartridge case. Primer is for the ignition of the propelling charge. Pulling the lanyard moves the firing pin to ignite the primer. Then, the propelling charge is ignited also, and the explosive power from the ignition thrusts the projectile. Projectile of towed artillery is driven by the explosion force of the propelling charge. There are propellant grains located inside of the propelling charge. Inside of the 105mm size towed artillery's propelling charge are clothed propellant grains. Meanwhile, the propelling charge of 155mm size towed artillery comes in cylinder shape and the propellant grains sit inside. Propelling charge and projectile of the 155mm size towed artillery are separately placed. 155mm size projectile alone weighs more than 40 kilograms, and therefore, when the weight of propelling charge is added, the firing of it becomes more difficult. To reduce the weight burden, the projectile and the propelling charge are separately operated. In the case of the 155mm size towed artillery, projectile is placed first, and then the propelling charge is placed next. After placing the primer in, move the firing mechanism. When we draw the lanyard out, primer is ignited by the firing mechanism. In turn, the flame of a primer ignites the propelling charge. All the propelling charges are combusted with the explosion, so that there's nothing left inside of the powder chamber. To fully utilize the power of gas explosion, we need to make sure that the powder chamber is sealed tight. The bullet left from the power chamber passed through the bore. The bore sets the direction of the bullet to make sure the bullet flies toward the intended target. Also, the rifling makes the bullet spin. Spinning bullet can minimize the disturbance induced by air resistance so that it can go straight toward the target without wobbling or flipping. There's a belt-shaped band called rotating band. The rotating band is made of copper alloy which is softer than the inner wall of the bore. The diameter of the rotating band is slightly bigger than that of the bore. Therefore, the rotating bore gets pushed inside of the bore and is geared into the rifling and rotates along the rifling. When projectile is fired, its surface receives air resistance. Therefore, the frontal part of the projectile should be designed in ways that could minimize the air resistance. The turbulence occurring at the back side of the projectile also interrupts the movement of the projectile. To minimize the occurrence of turbulence, the rear part of the projectile are designed with slopes. A towed artillery is used to attack various kinds of targets, including buildings, vehicles and enemy troops. Since these targets vary in thickness or material, different types of projectiles are utilized. These are high explosive, illuminating, and smoke projectiles. The most common type of projectile is the high explosive type. There's TNT explosive in it. The whole 155mm size projectile weighs more than 40 kilograms, and the weight of TNT is about 7 kilograms. Generally, the weight of the projectile is on par with the weight of the body. When the explosive goes off, the body splits into 2,000 particles and scatters. Due to the heavy air turbulence that follows the explosion, the metal splinters cause serious damage. The casualty radius is about 50 meters. The in-range of 155mm high explosive is about 18 kilometers. There's rocket assistant propelled projectile, which has a more extended range of shot with the help of the rocket motor placed at the rear of the projectile. Since the RAP is large and heavy, a propelling charge with reinforced explosive power is used. In range of the RAP is about 30 kilometers wide, but it has disadvantage of having a weak warhead. The high explosive used in 105mm towed artillery weighs about 19 kilograms, while the projectile alone, excluding the weight of the cartridge case, is about 15 kilograms. There's 2.1 kilograms of TNT in it, and the casualty range is about 15 meters. The in-range is about 11 kilometers. This is a 105mm sized white phosphorus smoke bomb. When the buster explodes by the fuse, the burst of the body scatters white phosphorus in it. And when the white phosphorus contacts the air, it creates heavy white smoke cloud. The white phosphorus is also used in the illuminating and the incendiary bomb. This is a 155mm sized illuminating bomb. the luminary and the parachute are inside the bomb. When the rear part of the projectile is thrown off upon launch, parachute spreads out, and the luminary is set aflame. The luminary is used as lighting at war during nighttime or at times of low visibility. This is a 155mm incendiary ammunition. The incendiary ammunition is the type of bomb that inflicts damage with flame. The flaming power of the bomb is strong so that it's not easy to extinguish the fire. However, in consideration of the potential damage to civilians and environment, it is generally avoided at war. Family of scatterable mines is a bomb that scatters a large number of mines. One type of it is an anti-personnel mine, and the other one is an anti-tank mine. To look at the former, a DAM is shipped by 155mm size projectile and contains 36 anti-personnel mines. When the projectile is fired, the mines are scattered in the target area. On the other hand, RAAMS mine is shipped by 155mm size projectile and contains 9 anti-tank mines in it. The projectile is fired and the mines are spread out in the targeted area. Also, there is precision-guided munition that uses GPS. At the frontal part of the projectile sits a fuse. A fuse is a device that ignites the explosive charge in the projectile. When the fuse is activated, supplementary charge is ignited, leading to the explosion of the main explosive charge. As the main explosive charge is not readily activated by external turbulence, supplementary charge is required to help the explosion. There are different types of the fuse: impact fuse, the proximity fuse, and time fuse. The impact fuse is a fuse that works when it hits a target. Then, there are two types of impact fuse. The first one is a direct action fuse which explodes as soon as it touches the target, and the second one is a time delay fuse which explodes after a brief moment. The shock fuse has two primers. One is above and one is below. There is an interrupter in the middle of the fuse. When the shell is fired and rotated, interrupter is pushed out by centrifugal force. This will open the middle path, allowing the flame to pass through. When the shell collides with the target, the firing pin hits the detonator. This ignites the detonator, and flames descend down the middle aisle to ignite the supplementary charge. When the shell collides with the target, the detonator underneath is also activated. But the lower primer works about 0.05 seconds later than the upper one. So, if the primer above works normally, the primer below is meaningless. Turning the screw prevents the interrupter from sliding. That way, the flame of the detonator activated from above will not come down. In this case, the fuse is activated by the primer operated from below. As a result, the fuse is delayed by about 0.05 seconds. When it comes to the buildings, it is much more efficient to have the bombs explode inside the building rather than on the outer wall. The speed of the projectile is quite fast, so it takes little time to pass through the inner structures of the building. Time delay fuse is designed to go off after penetrating the target. The time fuse is the type of fuse which induces explosion after a certain set time. It controls the exact explosion time using clockwork like that in a clock. Another form of timed fuse. If the firing pin above ignites the primer below will also ignite. There is a metal ring under the detonator and gunpowder inside. When the flame of the primer ignites the gunpowder burns for a certain period of time. When the gunpowder burns to the end, it ignites the supplementary charge. This type of timed fuse is called a combustion time fuse. As such, as long as the speed, trajectory and the distance from the enemy are known, the bomb can be set to explode at a precise time. The optimal operating height of the 105mm projectile is about 15 meters above the ground. Since a large number of fragments are fallen on the enemy's head, it can be the most destructive form of attack. In the case of illuminating bomb, it is usually set to airburst at a moderate height. Finally, the family of scatterable mines is induced to operate at a pre-calculated optimal height for the most effective operation. Proximity fuse is a type of fuse which explodes at the nearby side of the target. The fuse has an electronic transmitter so that it can measure the distance between the target and itself. It shoots the electromagnetic wave forward and checks the returning wave to measure the distance at which it needs to be exploded. By using proximity fuse that explodes in the air, you can attack the upper side of the armored vehicle. Moreover, you can neutralize the infantries who are scattered around the area or in hiding. Thank you for watching till the end.